Okay. So my name is Erica, and I have a BFA in graphic design from the University of Massachusetts, Dartmouth, and an MFA in book arts and printmaking from the University of the Arts. I am a book artist, a printmaker, and a paper maker. I teach undergrad and graduate printmaking and letterpress, and I'm a master printer in offset lithography. I print with and for other people, students, and artists. Today, I'm coming to you from Common Press, the letterpress and book art studio at the University of Pennsylvania, which is sponsored by Penn Libraries, the Weitzman School of Design, and the Kelly Writers House. Common Press is open to all students, faculty, and staff at UPenn, and the majority of the people using the press are studying or working in fields not directly related to art. Common Press is within the UPenn Libraries, as is our collaborator on this project that I'm going to be sharing with you. Mary Tasillo and I have been working with Lexi Voss to produce 3D printed type that can be printed alongside wood type with nearly indistinguishable impressions. So running out of sorts is a problem that letterpress printers are all familiar with, especially when working with wood type. Some of the fonts in our wood type collection at Common Press are missing a character or two. And with some fonts, like this one, we're missing more characters than we actually have. I still want to be able to use this type and print from this font. Another problem we're frequently working around is how to print accents above letters when the font we have in our collection doesn't have any accents. Here, a student repurposed a comma in order to be able to accurately print the author's name on a broadside for their reading at the Kelly Writers House. Many people who come to the press are interested in printing in languages other than English. People want to print in their own native languages, a language they're studying in school, or the language that something was originally written in. We need more type with accent marks to make that possible, and it would be great if we had more type in non-Latin alphabets too. My personal interest in this 3D printed type project is also to figure out a more affordable, accessible, and efficient way to produce the type for fonts that I design myself. So we have been developing SLA printed resin type with removable diacritics. SLA printing, or stereolithography, is an advanced 3D printing process with the ability to produce high accuracy, isotropic, and watertight parts with fine features and a smooth surface finish. Before learning about the SLA machines, most of the 3D printed type I had seen had this very distinct look to it, and it looks like all of this type was printed with filament. Printing with filament is a lot like 3D printing with a hot glue gun. It can be inconsistent with very visible layer lines, an uneven surface, and requires a lot of post-processing like sanding or coating the face of the letter with some other material in order for it to letterpress print smoothly. Although many people have embraced the look of this type, we knew it wasn't going to work for us since it prints very differently than wood type. In the top left corner, you can see a model inside of a 3D printing machine, and take note that the build platform is on the bottom and it is printing from the base up. Here's one of our pieces of type in the SLA machine. Notice that the build platform is upside down and at the top of the machine, and in the base of the machine is a tank of liquid resin. Each layer is cured with a UV laser as the build table rises, lifting the model from the liquid resin. The orientation of the type is really important. We need to make sure that there are no concave or hollow parts of the form that could trap air between the type and the resin tank, which would create suction forces called cupping. Cupping can cause a separation between 3D printed layers, structural defects, warping, and print failures, all of which can damage the resin tank and thus damage the 3D printer. Before we identified which wood type font we wanted to complete, we started making prototypes with a variety of ampersands. So here is Lexi's CAD drawing fitting the block around the character and plugging in the measurements to make them type high. Lexi has been doing the vast majority of the file prep and 3D printing, and then we proof the type and send her detailed feedback. She makes adjustments, brings us more type, and so on. Models typically print best when flat surfaces are oriented at an incline of 10 to 20 degrees, which reduces the surface area of each layer and helps keep the geometry as stable as possible. In this case, tilting the letters also avoids cupping to increase the chance of a successful print that is true to size. If you look at the enlarged ampersand, however, you may notice the stepping along the curves or what looks like pixelation. This is evidence of the layer lines from the 3D printing process and is not ideal for what we're trying to do. On the second round of prototypes, the letters were reoriented, and we also tried some post-processing surface treatments in hopes of minimizing those layer lines. The post-processing makes room for human error and also added unwanted visible surface texture to the letterpress print. But when we proofed this type, we found that the surface treatments weren't necessary. So if you look at the enlarged ampersand, you may now notice how it has nice, smooth curves with no evidence of layer lines. So we overcame the first hurdle. We made type that prints well. We can now create type to complete our wood type fonts, or we could 3D print whole new fonts of non-Latin alphabets. And of course, we could just 3D print one set of characters with accents and one set without, but that can take up a lot of space. And we were asking ourselves, what is something that we can do with 3D printing that we couldn't do otherwise, or would be much more difficult to do otherwise? So we asked Lexi if we could create some sort of modular type with removable or replaceable diacritics, and here are her initial sketches. And then here's the first prototype. It's a bit larger than the wood type font it was made for, and it misprinted with ridges, but the accent fit in the slot really well. It didn't wiggle side to side, it tipped back and forth vertically when it's not locked up, but once it's on the press bed, it's immovable. On the next batch of prototypes, which I just proofed last weekend, Lexi corrected the size and printed both the type and the accents at different orientations. The image on the left shows the type 3D printed at the previously identified optimal orientation, but we also tried 3D printing the type with the supports attached to the foot, like in the image on the right, just for comparison. However, printing at this orientation meant that we had to punch the counterforms all the way through to the foot to prevent cupping, as you can see in the ampersand. And it also meant that we had to sand the foot, which meant more room for human error and more likelihood that the type would be an inconsistent height. So here's the print. The top row is 3D printed with the supports attached to one side of the type, which we found to be the optimal orientation. The bottom row is 3D printed with the supports attached to the foot. And you can see that the top row has a more consistent impression, and the type in the bottom row has that inconsistent impression due to my human error. The triangular post doesn't have quite as tight of a fit as before. There's lots of horizontal movement. And the accent piece wasn't quite type high, so I had to do a little masking tape make ready to get it to print better. So the accent mark that was printed with the supports attached to the short edge had the best fit. And again, the type that was printed with the supports attached to one side of the type rather than the foot is the optimal orientation. This is a scan of the print of the A's. So after the type is 3D printed, all we have to do is pop the type off of the supports and lightly sand one side of the type that was attached to the supports, and then it's ready to letterpress print. Here is the resin type printed between wood type, and it works. If the wood type wasn't dented or worn, the impressions would be indistinguishable. It has a really nice impression with lovely smooth curves and no evidence of layer lines. So we're currently working on printing some consonants and refining the dimensions of the post under the diacritics for a better fit. And we're not the only ones 3D printing type. If you're interested in learning more about using experimental digital technologies to create type for letterpress printing, Nicholas Silberg of Carport Press is teaching a workshop at Penland this summer, so you should check that out. And lots of other people are experimenting with 3D printing too, but our innovation is the modular aspect, the removable and replaceable diacritics. This will help us at Common Press to foster a diversity of voices in letterpress printing. We can complete the fonts in our collection, we can produce new fonts of movable type in non-Latin alphabets, and it will allow for people to print in their native languages and to print texts in the original language in which they were written. And someday, when I finish designing the font, I'll be able to 3D print it and have it in movable type too. I just wanted to give another shout out to my collaborators on this project, Mary Tasillo and Lexi Voss. Thank you both for all of your work. And thanks to Partners in Print, Jenny, David, and Josue for inviting me to share this with all of you today. And thanks for listening.